In this video session, we have to look about the CPU and the operations of CPU. So before that, what is CPU? CPU is a brain of the computer system. So generally, we know that CPU is the brain of the computer system. The particular part is considered as a hardware part. So CPU is a hardware. The particular component is controlling all of the activities within the computer system. So that's the thing. So CPU extends. That means CPU means Central Processing Unit. So Central Processing Unit means we call it as CPU. Generally, in our computer system, CPU manufacturers are there, right? There are so many CPU manufacturers are there. Different computer types are having different named of manufacturers. That means sometimes we may have that Intel CPU. Sometimes we may have AMD CPU, M1, M2, M3 up to M4. Apple companies CPU brands are available nowadays. So like that way, CPU is the major thing in the computer system. So once we are buying a computer as new, then we have to worry about the CPU model, Central Processing Unit. So once we are choosing a particular suitable computer system, we have to choose the correct CPU. Then only the performance will be increased. The performance of the computer, that means speed of the computer, we can take as a speed. So speed of the computer is depending on the CPU. So I'm typing here in a Google window CPU. So generally we have to know about the CPU. CPU is a central processing unit which is consist of multiple hardware inside. So in here you can see the definition of the CPU. CPU stands for Central Processing Unit, and it's the primary component of the computer that acts as its brain of processing data, performing mathematical operations, and running the operating systems and applications. Without the CPU, the computer system can't execute it. So this is the thing. So the other thing you have to know is what about the hardware appearance of the CPU? So there are several companies protecting CPU for the computer system. The major CPU model we called as Intel. So Intel is a company which is having so many versions of CPUs. So Intel CPUs are very famous. i3, i5, i7 CPUs are available. And Apple company also producing some kind of CPUs. Apple Bionic chip, M1, M2, like that way. It up to M4 chips are available. Still 2024, right? So this is a CPU. The part is controlling the computer system. This CPU is consist of multiple hardware components within the CPU. So we'll one by one see what are the hardware components within the CPU we are having. So first component we are having within the CPU is CU. So CU stands for control unit. Control unit. So control unit means this is a unit which is controlling all of other parts in the computer system. By using of its name, you can identify what's the activity of the CU. So control unit, it controls all of the controls of data and the instructions within the computer system. So second component we are having within the CPU is ALU. So ALU means arithmetic and logical unit. So arithmetic and logical unit is a other hardware component. This particular unit is responsible unit for the arithmetic and logical operations itself. So arithmetic means generally, that means making some calculations, addition, subtraction, then multiplication, division, like that way we are having multiple arithmetic operators. These operations will be managed by this ALU. Then what about that logical unit? Logical unit means comparison, greater than, less than, equal or not equal, greater than or equal, less than or equal. So these kind of logical operations and or not, these operations also considered under the ALU. So ALU and CU are the two major components or hardware components within the CPU, and we are having registers also. So registers are the smallest computer memories and volatile computer memories. We covered in the previous session. So the previous session is mentioned in the description part. Through the description link, you can view the particular YouTube video and you can enhance your knowledge. So what about the registers? Registers are the computer memories, very smaller memories. And these kind of memories are volatile. That means temporary memories. Not only a particular register is within the CPU. There are multiple registers are available within the CPU. So registers means these are the computer memories. They are having the very small amount of data within the computer system. So very small amount of data means like KB measurable data. So what is a KB measurable data? Nowadays we are utilizing the RAM with the GB measurable. 2 GB, 4 GB, 8 GB, 16 GB. There are kind of uh, capable varieties are available in the random access memory. So once we are buying a hard disk, we are ready to buy with the TB measurable capable. So TB means terabyte. Like that way, GB, TB, megabyte, terabyte, gigabyte, these are the measurements. But in the registers, we are storing the data in the KB level. 1 KB, 2 KB data can be measured, that means stored within the registers. There are kind of registers are available. For an example, memory buffer register, memory address register, general purpose registers. Like that way, we are having multiple variety of registers. These registers are responsible for multiple variety of respective operations within the CPU. So in here, I have added some kind of registers and the operations of registers here. So the first register, the first type of register we have to see is accumulator. So in this window, you can see this one. So accumulator. It is a register. It's a kind of register. The short form of accumulator is A. So this accumulator is storing the instruction which is needed for the ALU. The instruction utilized by the ALU will be stored within the accumulator. And the program counter is another type of register. Program counter is shorthanded as EC, program counter. So this kind of register is storing data and it is identifying the next instruction which is run by the CPU. So this is very important register which is identifying the next instruction for the execution of the CPU. Then here there are several type of registers. Instruction register or current instruction register, both the same, IR or CIR. So this is a kind of register which is storing the data which is driven from the RAM. RAM means main memory. Then flag register or status register. So this flag register stores the status of the last operation carried out by the ALU. So the past operation, the recent past operation, which is stored by the flag register. So like that way, we are having memory address registers, memory data registers, memory buffer registers, condition code registers, general purpose registers. There are several general purpose registers are there. These kind of registers are shorthanded by MAR, MDR, MBR, CCR, and GPR. So these kind of registers are available within the CPU. But anyhow, we have to know the registers are the common terms. These kind of registers are inside within the CPU. So these registers are storing the data temporarily. So these three kind of components, physical components, are located within the CPU. So now the topic is how the execution is executed or run within the CPU. So in the previous video also I have mentioned the CPU is the major component. The particular CPU is having several operations within the computer system, the CPU is getting the instruction directly from the main memory. So main memory means we called as RAM, right? So from the RAM, the CPU will get the instructions or the data. So now our topic is how the data from the RAM is executed within the CPU. So CPU, we are having several hardware components. The first component we called as CU, ALU, then register. These are the components. So initial thing, IR, OCIR. So this is a kind of registers, IR, OCIR. This IR, OCIR will get the data from the RAM and they will store the data itself. So from the RAM, the data will be gathered into the IR or CIR. Both the same. Then this is a kind of registers. So this activity is called as fetch the instruction. So initial one we called as fetch the instruction. From RAM to CPU, the instruction will be fetched. After the fetch of the instruction will be decoded. This decoding activity will be done by the CU. CU means control unit. The control unit will decode the instruction. So decoding means what? Decoding means finding the actual purpose of the instruction. Sometimes there are several calculations, maybe they are the operations. A plus B into C divided by Z. There are several operations by it. That means executed within the instructions. But these operations will be decoded by the CU. So initial one fetch the instruction will be happened within the IR or CIR. Then the CU is the responsible part for the decoding. Decoding the instruction. Decoding the instructions. Then ALU will execute the instruction. ALU is the part that will execute the instruction. It's a part which is responsible for the arithmetic and logical operations. So executing the instructions. So these three activities are the major activities within the CPU. Fetch the instruction, decode the instruction, and executing the instruction. There are three kinds of hardware components are responsible for these three kinds of activities. So that's why we combine these three activities and we named for these activities are called fetch execute cycle. So sometime you have to know about the fetch execute cycle. So fetch execute cycle means the kind of activity within the CPU. The instructions or the data driven from the RAM and it will be executed within the CPU. Within the CPU, we are having multiple hardware components, IR, CIR, CU, ALU, and these are the three components. They are handling major activities of the fetch execute cycle. So this is the thing which is happening within the CPU. So in here, we have to worry about the fetch execute cycle. So fetch execute cycle is not only the single instruction execution. So 5 plus 3 plus 7 minus 2 divided by 4. Consider about this operation. So initially we have to do 5 plus 3. The result will be there. With the result, you have to do the calculation with plus 7. The results will be there. With the results, you have to do the calculation again. So again and again, the calculations will be done by the CPU. This is only the one-time execution. It will be done as a cycle. So that's why we call it as fetch execute cycle. So once we are worrying about the fetch execute cycle, the fetch the instruction, decoding the instruction, execute the instruction finished in the first time. Then again the data will be fetched from the main memory to the CPU. Again the data from the RAM will be decoded. Then again the decoded data will be executed by the ALU. This is a cycle. It won't finish. Again and again it will be done as a cycle. So that's why we call it as fetch execute cycle. So again and again we are running, okay, that's fine. So how we can find the next instruction? It is consider this a very complex calculation. So 5 plus 3 is there, then the answer will be there, then 7 will be calculated. So these data will be stored within the RAM, isn't it? So now the RAM is the responsible part that should transfer the data in a correct order. Then only you will get all of the data within the CPU in a specific order. You can do your calculation in the correct way. So that's why we are having a register called PC, program counter. So program counter is a register which is ordering the instructions. So sometime you may ask, what's the purpose of the program counter? So program counter is a kind of register which is identifying the next instruction of the execution, which is identifying the next instruction for the execution. So that's the answer. So PC is a kind of register which is identifying the next instruction. Sometime you can write program counter is a register which is storing the next instruction's memory address. Because once you are storing the data within the RAM is identified by the memory address. So memory address means you can identify 1, 2, 3, like that way you are having multiple memory addresses here. So once you're having a memory address, the RAM is allocated within every memory addresses, the data or the instruction will be there. So program counter will identify which instruction should be transferred to the CPU. Finally, the particular CPU will execute the particular instruction. So that's the thing. So program counter is a register which is storing the memory addresses of the next execution. So these are the basic things under the fetch execute cycle. So if you need some images, you can go through the Google. So I searched something from here. It's a Google window. Fetch execute cycle. So fetch execute cycle, also known as the fetch decode execute cycle, is a computer basic operation that is involves the central the processing unit, CPU. The processing instructions, there are some order. Fetch, decode, execute, repeat. This repeat is not important to you. Repeat means again and again the instruction will be executed. So fetch means the CPU loads the instruction from the main memory into the registers. The program counter holds the memory address of the next instruction. So this is important. So you have to know fetch means you are getting the instruction from the main memory into the registers. So which kind of registers? IR or CIR. IR or CIR is a kind of register. The particular register is storing the instruction from the main memory. Then the program counter holds the memory address of the next instruction. So program counter is a register which is holds or store the memory address of the next instruction. Then decode. Decode means the CPU decodes the instruction here. Execute means the CPU executes the instruction. So decoding activity is responsible by CU. Executing will be done by ALU. So this is the topic. So in here, additional passage is added with you. The fetch execute cycle, also called as von Neumann architecture, named the Hungarian-American computer scientist John von Neumann. Von Neumann ideas was stored program in main memory, the computer, and fetch execute instruction one time into the CPU. This is additional knowledge. So this is the topic you have to cover under the fetch execute cycle. There are several images can be represented for the fetch execute cycle. But you can refer some images that are very famous in fetch execute executions here. So I searched those images from the images part from the Google. These all images are not relevant for this fetch execute cycle. But in general, you can refer this image. So I'm referring here. So fetch part will be done initially, then decode part will be there. After that, the execution will be done by here. So three parts will be there. So most relevant image execute cycle you can refer is this one for this image. Fetch, execute, decode, and storing the instruction. Okay, you can see this window here. So this is the topic or this is a relevant image for you. First one, decode. So decode is considered under the control unit. So this image is very relevant to you. Then arithmetic and logical unit, it is responsible for executing the instructions. Then within the RAM, we are having stored methodology. The executed instruction will be stored in the RAM. RAM means main memory or the primary memory. As fetched from the RAM also. The instruction will be fetched into the CPU. This is the RAM part. They have mentioned this is the RAM part. These are the components within the CPU. That's the thing. Then the fetch instruction will be stored within the IR or CIR. IR or CIR. So these are relevant images for the fetch execute cycle. Then program counter is a kind of register which is storing the memory address of next instruction. So these are the things under the fetch execute cycle and the CPU operations in the computer system.